Is up, world? I'm back with 2 Time Graphics. We're gonna finish up this 3-part series of just lighting in general, where we did ambient shading, diffuse shading, and then specular shading is this episode. So let's just dive right into it, get this over with. This shouldn't be the longest episode in the world. We're gonna add a couple more GUI things to control what the model looks like, and then it should be fairly quick. So the way specular lighting is, what is specular lighting? Okay, specular lighting is the shiny part of any object in your room that might have a shine on it. So you look around. Some things are more matte, some things absorb more light, some things reflect more light. And what like pretend this is a little metal ball. If this were the light right here and it was shining at your eye and you can see basically a mirrored reflection of the light, that is the specular lighting. Move my cat. There you go, buddy. There you go. He might come back up here. He kind of wants to come back up. Oh well. So that's basically lighting. To calculate the specular lighting now, so before we took the light direction and the surface normal and we applied the diffuse based on that. With specular lighting, we are going to be using the surface normal light direction, except we're going to take this light direction and we're going to flip it over the normal. So we're just going to invert it so we get that exact point in which the light is reflecting to. And then we're going to take our eye position, right? So if our eye position is right here and it's looking at this reflection, it's looking at this reflection, we can take just like we took the dot product of right here. We took the dot, it's like just a dot. We can take the dot product of right here, give us a value from 0 to 1, and multiply that by the specular intensity, just like we did times the diffuse intensity. Now, we'll also need to apply a shininess factor into exactly how shiny this object is. So that's what we're going to do. Let's do that. Let's do it real quick. It's not going to be hard. Yeah, that's basically this is how specular lighting works. It's a little bit more complex than the other lighting calculations, but it's not too bad once you kind of visualize it and you can see exactly what's happening. So I'm going to put this over to the side real quick. Let's put it right here. Right there. Okay, so yeah, so we're going to start in the shader. Let's add Specular Color. And then I'm going to go just down here, float 3, Specular Color. And then we're going to add it right here. So just like I said, it's in last week's episodes, we add these 3 colors together, this one plus this one plus this one, and we get this specular color factor. However, we need to do some stuff before that, such as get the eye position. So in our image, we have our eye position. We don't have that yet. We have our light direction and our normal, but we don't have our eye position. So let's go ahead and get that and then normalize it. So basically, we're just going to go vertex out. We're going to say float 3 eye position. And then we're going to set that. So you can find the eye position by just doing this calculation, model view matrix time, this is model constants, obviously. Model constants dot model view matrix. We're going to rotate that by the VN dot wherever the position is, and that's going to give us the eye position right there. So we're going to get the X, Y, and Z factor. So that'll give us the eye position. We have the eye position. Let's take it into the fragment shader. So we'll say float 3 unit eye equals normalize VN dot eye position. So now we have the unit eye position right there. So in order to get this specular color, we can take this eye position and one other position we're going to kind of need that we're going to do in the fragment shader is we need to get this reflected point. So there's a built-in function into the in metal called reflect, and what that'll basically do. Okay, get out of here, dude. He's chasing the mouse. What that'll do is it'll basically give us whatever this is in comparison to the normal. It'll just reflect it right over that. Or you can really reflect over anything. So you can reflect over the ground to give you. So if you wanted to look, if you're looking down, you can see a reflection of the whatever's in the distance. So you can work in it that way too. But yeah, so we're just going to use this reflect function. So float 3, and I'm going to call this the what am I going to call this? Reflection point, I guess, just reflection, equals take the reflect function and just pass in the light dot direction and the unit normal. And that's going to go just right over. Oh, I think my cat's playing with my cord. Man, this is a little intense. Okay. So that'll give us the reflection over the point. So if I look at the image again, that'll give us this point. So we're going to reflect over the normal, just like that. I know I'm repeating myself, but it's good to repeat yourself. All right, so now we'll take the reflection. Now, in order to find the specular factor, so float specular factor, we're going to need to do exactly what we did right here with the dot product, right? So we already found this dot product. So I'm going to take that. Like I said, just find this, and then we're going to take in the light, the reflection, and the eye position. So reflection, reflection, and the unit eye. All right, so this isn't the full specular factor because we now need to take into consideration the shininess of the object. And so we get this point, but we're going to need to take the power of it to the shininess, whatever we pass in. And we don't have that right now as of yet, so let's do that. Let's add that. So we're going to have vertex out, so float shininess. And we're also going to need the float specular intensity. Ignore the specular intensity for now. I just want to have it. Actually, you know what? I'll just take it. Yeah, I'll leave it in there for you now. Okay, so I don't want to confuse too bad. So here we go. So we're going to take the power of whatever we get from that dot product just to the VN dot shininess factor. Okay, so that's going to output whatever specular dot we're going to be multiplying by. So it's going to get a 0 to 1 factor and then the shininess. So it's really shiny. It's going to use that small number, the 0.5, and it's going to make it more shiny. And then the intensity is going to be used in the next calculation, which gives us our float 3 specular color, which we already have. I already did that. Equals the specular factor. Nope, sorry. Just like before, we need to do the light dot color times the specular factor. Now we also need to take into consideration, like I said up here, the specular intensity. So how intense is this going to be? Is it going to be very intense, little intense? And so we're going to multiply that by the specular intensity, just like we did above. But okay, so times Vn dot specular intensity. So like so. All right, save that. That should be working good. Now we just need to pass it out of the vertex out. So these factors, the shininess and the specular intensity factors, are going to be applied to the model directly. So we're going to need to do them on the model. So I'm just going to copy these, put these right here on the model constants. And we're just going to pass them in on the model constants. And then we'll say V out dot shininess equals V in. Model constants dot shininess, and then V out dot specular intensity equals model constants dot specular intensity. So now looking over it, looks good. That'll give us our color, and then we just need to do add it. Okay. Yeah, so that should be up and running. So now that we've applied this to the model constants, we'll want to do that in the types here. So let's go here and we'll go var shininess equal, which is going to be a float, and we're just going to make it 0.0 to start with, and then var specular intensity float equals 0.0. Okay. On our node, we're going to add these here because they will be on our model, or any object will have a intensity rating. So var specular intensity float equals 0.0. And in our model, where we're rendering this model, we can just say model constants dot shininess equals shininess, model constants dot specular intensity equals specular intensity. So now we're just passing in these values from our model into the shader. That was pretty simple, right? So now that was just like step by step. We're basically done in doing the calculation and the passing. Now we just need to go to the scene and pass this in. So I can go movable object dot shininess equals, well, let's do like so shininess is a value from 0 to 128 according to the I think it's material coefficients. So I found this image online. It's pretty sweet. It's kind of bad. It looks like an image of an image of an image of 5 more images. It's really bad, but other than that, it gives you these values of the shininess. So if you give it these values right here, you will get something that looks more emerald. And if you put in this, you'll get more copper. But at the bottom it says multiply the shininess by 128. So shininess can be a value from 0 to 128. Let's give it like a 5 shininess, and then we'll give it a movable object dot specular intensity equals I don't know, this is value from 0 to 1. I'm just going to give it a 0.8. Sure. And so now that that's set and it's all getting applied, we're just going to run it and see if it's working. I think it should be just fine. Oh, that was quick. Wow. Let's check the time. We're at 12 minutes and 52 seconds. Oh, okay. So it looks like I'm just specular intensity v out model constants dot specular intensity. Oh, that is a yikes. Okay, that should be good. What's your deal? No, I removed that. Oh, I did it up here too because I copied it. We can update to Swift 4. I'm not going to do that yet because I don't want to lose some of the things I already kind of have built. And I need to make sure that works. See, so now we have this shininess, so let's add a little bit more diffuse to it. And we get that beautiful shine. You see, like the light position is right here, right pointing at 0, 0, -1. And so you're getting basically the shine factor from this model now. Now, what I want to do is go into the main storyboard, and I kind of want to generate some more of these right here, some of these sliders to do that with. So let's go to the preferences and add a few properties. So I'm just going to take this, copy it twice. I'm going to say instead of diffuse intensity, this will be specular intensity, and this will be shininess. And just like we did here, we're going to copy that, put it down, and then this will be specular intensity. And then we can just take this specular intensity and put it right here. Let's go to the shininess. Let's put this right here. Oh. Set shininess. Okay, so now we can call that from our main storyboard in the view controller. And then we're just gonna we're gonna drag, and then we're gonna hold Alt, drag, and that'll make a copy of it. And then I'm gonna do that a second time for both. This will be Specular Intensity. Fix that positioning. This will be Shininess. Also fix that positioning. And we need to bring up the view controller over here. So we're gonna attach, we're gonna make 2 more text fields for these 2 right here. So we're gonna go copy, paste, paste. This will be the Specular Intensity. This will be the Shininess. And so we're just gonna drag, we're gonna control drag from here to Specular Intensity for that text, and then we're gonna control drag from here to the Shininess. So now those are connected. Let's just connect the 2 sliders now. So this would be Specular Intensity. That'll be from 0 to 100 like we said. This will just need to be txt Specular Intensity, and this will be set Specular Intensity. Probably get rid of these guys. Get rid of this and replace it with Specular Intensity. Just like so. And the same thing for this, except it's Shininess. Just like so. Alright. Bada boom. Now we just need to control drag. Well, let's kind of want to move this down just a hair. Yeah, move both these guys up just a smidge. That looks right. Yep, so now I'm going to control drag this one to here, control drag this one to here. Okay, that was simple enough. Let's just go ahead and update the positioning of these in the window. So we're going to first update. Oh, well, I guess we didn't move any of these around, so we don't need to update. But now that that's good, preferences set shininess, so we're updating all the shininess values and the specular intensity values, but we now need to apply it. So let's go to our scene and make another function. So just like we are here, we're updating our movable object. We need to update it in something else than update input. Update input is more for, even this is not right. This shouldn't be an update input. This is specifically for when keys are pressed. And so let's go ahead and go to our scene. We're going to add another one called func update model. And it's just going to do that. And we're going to call update input, and then we're going to call update model. So in our basic scene, we can override that func update model, and we can call all of this stuff from down here. So this would be preferences dot shininess. This would be preferences dot specular intensity, and we'll even put this up there because this makes more sense in here. Obviously this is only for this one model and not the whole scene, so I'll probably remove this at some point, but for now it'll show us what it looks like when we change the different values of the shininess and specular intensity values. So you might think shiny would be just glowing, but really that's not. If you were to shine light at a piece of chalk, the light would diffuse over the entire piece of chalk, but it wouldn't actually, looks like we need delta time. I'm not going to worry about that yet, so I'm just going to move him back under. And then I'm also going to comment it out so we can. No, I'm not going to comment it out because we want to see it rotate. Okay, so now that that's built, it should run. And one thing I always notice, see how it starts off like that? That's not correct. If you move the shininess just to 0.1, it'll change to this. This is the actual correct value. That's not. So it's pretty interesting. I don't know why that is. But you see, if we mess with these values right here, we get different outcomes. So this is only, shininess is 0 to 1. Like I said, shininess should be 0 to 128. So let's go back here to our main storyboard. Instead of dividing that by 100, let's do this. We'll divide it by 100. We'll just do float. We'll divide it by 100, and then we will multiply it by 128, so we don't have to necessarily set the thing. Couple more things I want to do is no, this is fine. This will work just fine. So diffuse intensity, shininess, see? So now it looks way more wet. The specularity is a lot smaller, or they're smaller dots because he just doesn't have, now you see like you can remove some shine on him so it's not the most shiny of objects. Reminds me a lot of Dark Souls when you add this shine because everything always seems wet in Dark Souls. But yeah, so if you remove specular intensity, shininess, if you only up the shininess and the specular intensity, you can see that we have this object. But let's make the clear color black, and you can see we can only see the specular lighting, and then we can add some ambient, and you can start seeing the color of that ambience. Add some diffuse, and yeah. So let's let me set the light color here. Oh, no, that's okay. That's okay. Yeah, let me see how that was quick. That was only 22 minutes. I have time to do some other stuff, some experimentation, I guess. No, I'm not going to do that either. Talk myself out of stuff. So we have ambient, shininess. We can add 2 of these things. We can add some more window setting. We can add, like, change the light color and the model color. Don't need them though, but yeah. So that's basically lighting in a nutshell. Let's just kind of recap over what we did in the metal. So ambient color. Ambient was an easy one to figure out. We just took in the light's color and then the ambient intensity we wanted to apply to it. So if we wanted kind of a red tinge coming from the room, you can apply that to the shadows of the object. The diffuse factor, or the diffuse color, was like the light spreading over an object based on which direction it was pointing, and then you can figure that out by using the diffuse intensity. This, let's look at the image. That's easy. So here's the diffuse. Here's the ambience. You see how it's a little red. Here's the diffuse values, and then for the specularity, we reflected this over to here, well, more so, reflected this guy over to there, and then once he was there, we took the eye position here. So you notice that this dot product is going to be kind of smaller, right? Or it's going to be like closer to 1. But if we were to take this eye and move him down here, and then right here would be the normal, or not the normal, excuse me, the eye position, there wouldn't be a specular because it would be behind and his eyes would be here, so that specularity goes away because the reflection of light goes right there, you see? That's kind of how that works. And then we just added the 3 together, and adding the 3 together gave us a beautiful shine on on our armadillo. Okay, so let's see from here. At some point, I'm going to come back to lighting. We're going to go over shadows. Want to put shadows on stuff. We don't have any shadows. That's another topic. We also want to do. I also want to do some optimizations right now. If you zoom into this guy, like I said, we're not actually culling the back or the front. In metal, it's front. But you can see, so you can you see he's rendering on the other side. So to optimize this, we don't have to render the back. And we'll make that optional because some things we'll actually want to cull all sides and some things we won't want to cull all sides. So we'll need to do that. Yeah, basically that's that for that. Then I think in one of the, really soon, we're going to start actually building a world based on the using this application. So yeah, without further ado, I'm just trying to think, make sure I covered everything. That was super quick. We got time. That never happens. Anyway, without further ado, goodbye, Crew World.